Today I am going to explain purification of water by using ion exchange method and desalination of brackish water by using reverse osmosis process. The first topic is purification of water by using ion exchange method. In the purification process, we are using the resins. Resins are also called as a polymers here. A polymer is nothing but it is a long chain polymer which is made by using various number of monomer units. Yes, so the polymer is also representing as a resin here. In ion exchange method, we are using two types of resins. One is cation exchange resin and the anion exchange resin. Before that, ion exchange method is one of the purification technique. It is removing all the cations in the water sample and anions in the water sample. Cations in the water sample are Ca+2 and Mg+2. That means calcium ions and the magnesium ions. Anions in the water sample are carbonates, bicarbonates, chlorides, sulfates and the nitrates. Cation exchange resin is removing cations in the water sample. Anion exchange resin is removing anions in the water sample. So now let us see the classification of resins or classification of polymers in the ion exchange method. The first type of resin is the cation exchange resin. Cation exchange resin is denoted with RH+. Here resin is bonding with H+, is nothing but cation exchange resin. But based on the strength of the ion exchange resin, cation exchange resin is two types. One is strong acidic cation exchange resin, weakly acidic cation exchange resin. Strongly acidic cation exchange resin, resin is bonding with the sulfuric acid, that is SO3H, whereas in the weakly acidic cation exchange resin, resin is bonding with the COOH. Yes, so this is the resin structure, this is the polymer structure. See, the polymer is repeating for n number of times and this polymer is bonding with SO3H. So that means it is the example, this structure is the example of strongly acidic cation exchange resin. Now the next one, anion exchange resin. This is anion exchange resin. Cation exchange resin was represented as RH. Anion exchange resin is representing as ROH. OH minus, that means resin is bonding with the OH minus, that is anion exchange resin. It is also two types, one is strongly basic and the weakly basic. In the strongly basic, resin is bonding with the quaternary ammonium, whereas in the weakly basic, resin is bonding with the amino group. Along with the amino group, it is bonding with the OH minus in the weakly basic. Yes, so this is the structure of anion exchange resin. This is the structure of resin, and here resin is bonding with the amino group. Yes, so this is cation exchange resin, anion exchange resin. In the cation exchange resin, H+ ions are replacing with the calcium and the magnesium, whereas in the anion exchange resin, OH minus is replacing with bicarbonates, chlorides, sulfates and the nitrates. This is the diagram for demineralization of water. The other name of ion exchange method is the demineralization of water. This is the diagram for demineralization of water ion exchange method. It is having the two chambers. The first chamber is called cation exchange chamber and the second chamber is called anion exchange chamber. When the water sample passing through the cation exchange resin, this is the cation exchange resin bed. Water sample is passing through the cation exchange resin, then H+ ions in the cation exchange resin is replacing with the calcium +2 and magnesium +2 in the water sample. Followed by the water is sending to the anion exchange resin with the help of pump. So when the water is passing through the anion exchange resin, anions in the given water sample. Anions are bicarbonates, chlorides, sulfates and nitrates are replacing with the OH minus in the water sample. So when H+ is replacing with the cation, this H+ will be releasing in the water sample. When OH minus is replacing with anions in the water sample, OH minus is releasing in the water. So this H+, this OH minus together formed as the water molecule. This water is also called as demineralized water. That means it is not having any minerals. So that is demineralized water. Yes. So now after some time these resins will be exhausting. Exhausting is nothing but the H plus ions in the resin are completely replaced with the calcium plus 2 and magnesium plus 2. Same OH minus ions in the resin also replacing completely with anions in the water sample. So there is no free H plus and free OH minus for replacing the new cations and new anions in the water sample. That means after some time these two are exhausting. So these we can't use by passing the water sample. So what we have to do? We have to regenerate this. Regeneration process is nothing but recycling process. This is regenerating. That is cation exchange resin is regenerating by washing with the acid regenerator tank. So the cation exchange resin is connecting with the acid regenerator tank. Whereas anion exchange resin is regenerating by washing with the alkaline regenerator. Here alkaline is nothing but base. So cation is regenerating by acid. Anion exchange resin is regenerating by washing with the base. So now let us see the reactions. So what reactions we have to see now? Replacing H plus ions with calcium plus 2 and magnesium plus 2 at cation exchange resin. Replacing of OH minus with anions, that is bicarbonates, chlorides, sulfates and nitrates in the water sample. And after exhausting, let us see the regeneration. That means this resin is washing with the acid, this resin is washing with the base. That is regeneration reactions. So these are the reactions at cation exchange resin and the anion exchange resin. This is the symbol of cation exchange resin, RH. But we know that H plus ions in the resin are replacing with the calcium plus 2 and magnesium plus 2 in the water sample. So when H plus ions are replacing with calcium plus 2 and magnesium plus 2, we will get R2Ca, R2Mg and releasing H plus ions in the water sample. Same at anion exchange resin, chloride sulfates are replacing with the OH minus. See here, OH minus ions are replacing with sulfates and chlorides at the resin. So we will get R2SO4, R2Cl and releasing 2 OH minus ions in the water sample. These are forming at the resin. At the place of H plus, calcium and magnesium are replacing at cation exchange resin. At the place of OH minus, anions are replacing at the resin. That means in the place of cations and the anions, cations of water sample, anions of water sample are regenerating or replacing. So now this H plus ion released from cation exchange resin, OH minus ion released from the anion exchange resin are reacting together to form water molecule. This water molecule is called demineralized water or deionized water. So now let us see the regeneration reactions of cation exchange resin and the anion exchange resin. So these are the regeneration reactions. Now we know R2Ca is forming at the cation exchange resin. So now it is treating with the acid. You can take any acid, hydrochloric acid or sulfuric acid. So when it is washing with the acid, Ca plus 2 will be replacing with the H plus. So we will get 2RH plus Ca, Cl2R, Ca2SO4. So this calcium chloride. Now we got RH. RH is nothing but cation exchange resin. This is one of the byproduct. This byproduct is removing by the washing. And same anion exchange resin also regenerating by washing with the base. We can take any base, sodium hydroxide or potassium hydroxide. OH minus ions in the base are replacing with sulfate ions and producing 2ROH, and this sulfate is forming as a byproduct with Na. So we will get Na2SO4. This byproduct also removing by the washing process. So these two are the regeneration reactions in the ion exchange method. So now let us see what are the advantages and the disadvantages. Advantages are the process can be used to soften highly acidic or alkaline waters. That means this process is useful for acidic water and basic water. It produces water of very low hardness of 1 to 2 ppm. So the treated water by this method can be used in high pressure boilers. Yes, so the hardness of water from the ion exchange method is highly purified water. And this water is using in the boilers. Generally boilers are using for the power generation. Water is boiling in the boilers, and whatever the steam we are getting from the boilers, that steam is utilized for the power generation. So if we use the salt water in the boilers, the salt will be sticking to the boiler container and the boiler stiffness is decreasing and boilers are undergo materials are undergo corrosion here. So to avoid that we are using demineralized water in the boilers. Now let us see what are the disadvantages here. The setup is costly. That means this method is highly expensive. Whatever the chemicals we are using in this, those chemicals also very expensive here. The water should not be turbid. That means it should not having any suspended impurities like mud particles or the sand particles, and the turbidity level should not be more than 10 ppm. So it is acceptable up to 10 ppm turbidity. If turbidity is more than 10 ppm, it is not acceptable. If it is acceptable, the lifetime of the ion exchange method will be decreased. So those are the disadvantages and the advantages of ion exchange method. So this is the explanation for the ion exchange method. It is a single cylindrical chamber containing a mixture of anion and the cation exchange resin bed. But we are representing here two containers, two chambers here. But just for understanding only, we are representing two chambers here. But in the same chamber, the top part we are having the cation exchange chamber and the bottom one we are having the anion exchange chamber. When the hard water is passed through this bed, slowly cations and the anions of the hard water comes into contact with the two kind of resins many number of times. Hence, it is equivalent to passing the hard water many number of times through a series of cation and anion exchange resin. The soft water from this method contains less than 1 ppm or less than 2 ppm of dissolved salts and hence more suitable for the boilers. Yes, so this is the explanation for ion exchange method. So now let us see the next method, that is the reverse osmosis process. But before going to see reverse osmosis process, let us see where we are using the reverse osmosis process, what is meant by the reverse osmosis process. The next method is the desalination of brackish water. Yes, here brackish water is nothing but the water which is having more amount of salt concentration. Desalination is nothing but removal of salinity. Here salinity is nothing but saline nature or the salt nature. Removal of salt nature in the brackish water is called desalination process. So now let us see what is desalination. Process of removing common salt from water. Brackish water is nothing but water containing dissolved salts with a peculiar amount of salty taste. So that is mean by the brackish water here. Example of brackish water is the sea water. Sea water is having around 3.5% amount of salts here. So we are having one of the best technique, that is the reverse osmosis process. By using reverse osmosis process, we can convert sea water to pure water. So now let us see what is mean by osmosis and the reverse osmosis process. Here osmosis is the general process and it is a spontaneous process. Spontaneous process is nothing but the process which is natural. Non-spontaneous process is nothing but the process which done in the presence of external force. Non-spontaneous process is the artificial process which is done in the presence of external force. So osmosis is the spontaneous process, reverse osmosis process is the non-spontaneous process. Now let us see what is mean by osmosis and the reverse osmosis. When two solutions of unequal concentrations are separated by a semi-permeable membrane, flow of solvent particles takes place from dilute to concentrated side due to increase in atmospheric osmotic pressure, which is termed as the osmosis. So here two solutions of unequal concentration is nothing but one solution is having more concentration and another solution is having less concentration. So when the two solutions of different concentration are separated by the semi-permeable membrane, solvent particles will transfer from low concentration solution to high concentration solution. That is called osmosis. But what is meant by the reverse osmosis process? When we are applying the pressure at the opposite direction. What is the opposite direction here? Generally, solvent particles will transfer from low to high. So, if we apply the pressure at the high concentrated side, the solvent particles will transfer in the opposite direction. So, when a hydrostatic pressure in excess of osmotic pressure, that means more than this osmotic pressure, if we are applying at the high concentrated side, the solvent will flow is reversed from concentrated side to diluted side across the membrane. This principle is termed as the reverse osmosis process. So now by using reverse osmosis process, we are collecting pure water from the seawater. So here seawater is highly purified water and pure water is seawater is highly concentrated water and pure water is low concentrated water. So this is a diagram for the reverse osmosis process here. This is the chamber which is filling with the salt water and this is the chamber which is filling with the pure water, and these two solutions are separating with the semi-permeable membrane. Semi-permeable membrane allows only the solvent particles, it is not allowing the solute particles, and this is the outlet for removing the impurities here. Impurities are nothing but solute here. So just for better understanding, we are having one more diagram here. This is the semi-permeable membrane and this is the chamber filling with the salt water or highly concentrated water, and this is the chamber filling with the low concentrated water or the fresh water. But in the reverse osmosis process, we are applying pressure at high concentrated side. So when we are applying pressure at high concentrated side, solvent particles starts moving from salt water to fresh water. So here solvent is nothing but pure water, solute is nothing but impurities. So only solvent will transfer from salt water to fresh water. So like that we can collect high amount of fresh water in the reverse osmosis process. Yes. So now let us see what are the advantages of reverse osmosis process. It improves taste, odor and the appearance. Highly effective purification process will remove the pollutants listed above and more. So these are the impurities removing by the reverse osmosis process. Consumes no energy. Very convenient. Especially it is convenient in the domestic purpose. Flushes away pollutants, does not collect them. So it is flushes the impurities through this outlet. So no impurities are entering into the pure water here. Easy to keep clean because this membrane is removable. So we can remove the membrane and we can wash the membrane, again we can replace this. Low production cost gives you water of a guaranteed quality for pennies per gallon. So the production cost is very less. It is unlike ion exchange method. Ion exchange method is highly expensive. But whereas reverse osmosis process is very cheap, because of that reason we are using in the domestic purpose. So we know the cost of reverse osmosis RO purifiers around 4,000 to 10,000 or 20,000. So the cost will start from 4,000. So the production cost is very less for the reverse osmosis process. So thank you so much. With this we have completed ion exchange method and the reverse osmosis process.